During bridge service, bridge bearing capacity is related to bridge operational safety, whereas load test is currently used to inspect the bridge bearing capacity. The most direct and effective testing method. Load tests can verify the quality of bridge design and construction, evaluating the actual bearing capacity of bridge structures. Verify bridge structure design theories and methods. Dynamic response of bridge structure under dynamic loads, etc. So, do you know how to conduct load tests? In this lesson, let me learn the theoretical knowledge of bridge load test together. Load test is applicable in the following two scenarios. Scenario 1. Newly built bridges, or bridges that have been reinforced and retrofitted. Bearing capacity can be inspected through load test. Condition 2. Among in-service bridges, one of the following situations exists. Load tests can be performed. First, technical condition rating of class 4 or 5. Second, proposed load rating upgrade. Third, requires the application of special heavy vehicle loads. Fourth, suffering major natural disasters or accidental events. Next, let's first understand the types of loads a bridge bears, primarily including bridge self-weight, vehicle loads traveling on the bridge ambient temperature changes, etc. These loads will all induce responses in the bridge, such as deflection and strain, if the bridge's bearing capacity declines. When subjected to load effects, the bridge's deflection and beam bottom strain will increase. Deflection and strain are important indicators for evaluating bridge bearing capacity. Second, already constructed bridges. Bridge self-weight has already caused a certain response in the bridge, namely deflection and strain. Tests cannot measure self-weight, causing relative response changes in the bridge, namely the deflection and strain changes before and after self-weight loading. While vehicle load is a variable load, vehicle loads can be arranged on the bridge. Then, by testing the bridge response before and after loading, namely the magnitude of deflection and strain changes before and after vehicle loading, to determine the bearing capacity of bridges. Load test includes static load and dynamic load tests, respectively. The testing during vehicle stationary and moving states. Bridge response conditions. Before the load test begins, it is necessary to deduce the test load from the control load. Then, what is control load? According to general specifications for design of highway bridges and culverts, bridges on different road grades has corresponding car load ratings, respectively highway I level and highway II level. Different load ratings of vehicle loads. Load effects generated on the bridge main beam, becoming the control load, can also be referred to as bridge design load. The control load is the design load during bridge operation. During the testing process, with control load as the goal, back calculating test loads. Relationship between test load and control load. Refer to Formula 5.42 in Highway Bridge Load Test Specification, where S is the test load, S is the control load, mu is the impact factor, eta is the test load coefficient. Its range for new bridges is required to be between 0.85 and 1.05. For old bridges, required between 0.95 and 1.05. After knowing eta, mu, and s, then S can be calculated. The impact factor is related to the bridge fundamental frequency. Can be conducted in accordance with the general specifications for design of highway bridges and culverts, calculated using Formula 4.32. This content can be learned through bridge engineering courses. This will not be elaborated further here. Third, different types of bridges, having different most unfavorable stress sections, referred to as control sections. Highway Bridge Load Test Specification, Table 5.22. For different bridge types, control sections are also called test sections. Has been stipulated, tests must complete at least the main working condition testing. Fourth, Highway Bridge Load Test Specification, Table 5.32. Testing content for control sections of different bridge types has been stipulated. During testing, at least the main content testing must be completed. In the end, Article 5.5 of Highway Bridge Load Test Specification. For different bridge types and cross-section types, the number and position of strain and deflection measuring points are specified. Test measurement point arrangement must comply with regulations. 4. Dynamic load test content. Bridge dynamic load test should test bridge natural frequency and impact factor. When necessary, the bridge's dynamic deflection and dynamic strain should be tested. Dynamic load corresponding test conditions, including unobstructed driving test, obstructed driving test, and braking tests. In the end, I will summarize this lesson. In this lesson, we studied the adaptation of load tests, principle of load test, determination of static load test loads and arrangement of cross-section measuring points, testing content of dynamic load test. Bridge bearing capacity relates to operational safety. Therefore, in future load test processes, must not be careless to ensure our bridge safety. After class, please consider the following questions. When a bridge has multiple spans, how to select the test bridge span?